Welcome to this video. In this video, I'll be demonstrating an AI underwriting system. This is primarily built for an insurance organization. In insurance organization, the user, otherwise called as underwriter, is the one who creates the policy for the customers. Usually, they'll be getting the inputs from the brokers. The input could be in the email format or a PDF document or a Word document, whatever it is. Okay, so with that document as an initial input, many phases will be gone through. Okay, this will be like hours or even days for create a policy. In this case, I have made some agents which will not only speed up the process, it will also act intelligently. So this is my application. Here, I'm explained about this flow. User submits the document and the AI reviews the decision, and if the policy is going for a referral, which means another um, human has to intervene, that will go for a human decision. And what are the possible outcomes of this? It could be a plain completed vanilla flow. Otherwise, it can go for a awaiting underwriter decision. A human, a senior underwriter has to review. It could be declined. Say, for example, some mandatory inputs are missing, or some prompt injection, like vulnerable inputs in the document, or it could be failed because of some technical error. Okay, these are the possible outcomes. And then these are the primary six agents, which is part of this entire underwriter pipeline flow and creating the policies. Okay, I'll be explaining all the agents in very short time. Okay, so you can see I'm using two different cloud models, not only one model, because there is a reason I'm using it, because we don't want to have the high-end model like Sonnet for each and everything. IQ is slightly cost effective, and then also its speed, so we are using Cloud IQ for certain agents where I feel this is sufficient, or certain agents like evaluating the risk, underwriting risk or governance and all. We need a more reasoning capability of the agent, LLM. So that's why I'm going for the Claude Sonnet in that case. I've tested this application with some documents. These are all the sample documents. I'm not going to upload the Word or PDF document as I said, because that process involves OCR ability. I need to go for a Azure intelligent service, for which I need to pay some cost. So to overcome that, I'm just going to copy paste the content of a document which I already saved in some text file in this application. Okay. Yes, this is basically a multi-agent system with orchestration. I'm using LandGraph for the orchestration. For LandGraph is one of the um, popular framework for this kind of orchestration. And then tech stack, I'm following Python, the language, Fast API for the API services, and then Claude models. Already I mentioned the Haiku and Sonnet, and then I'm using the Postgres database. Um, Postgres database is not only a very suitable database in this case, because Postgres has an extension called PG vector that will support the capability of a vector database. In this case, on the claims agent, I am using a RAG concept, retrieval augmented generation. So instead of going a dedicated Pinecone or ChromaDB, I am using the Postgres database itself, where we have a provision for that vector database with the help of a PG vector extension. I'm connecting this database through Docker, so that means no need to install a Postgres database in the local machine. Through Docker, we can connect to the port what we specify. Okay, now I'll show the application, the code base. This is my application. Here the main file is source src. Under the source we have two different folders, in fact three folders: API, pipeline and platform. API is about the routes, whatever we have. Say for example health.py. Health.py is about a health check of this application. Whenever any external client calls this application, health.py is invoked, and it will check the status. Say for example database up and running or not, services up and running or not. So those things can be inferred from the health.py file. Pipeline.py, pipeline.py file is an service for this entire pipeline flow. um, and then we have submission.python file. This is for the document submission whenever we wanted to submit a data to the database, whatever we extracted from the document. So this is the API which is used. um, and then we have a pipeline and platform folders. Pipeline folder, we have all the agents whatever we saw in the UI. Those agents are mentioned here. The first agent is the document ingestion agent, followed by claims and hazard. Both the agents, this and this, uh, run in parallel actually. So this document ingestion agent is the one which will be triggered at the beginning itself. This will extract the fields from the document whatever we are using based upon the schema. It has, say for example, each and every agent has got two files, agent.py plus schemas.py file. Agent.py file is the one which gets triggered as the behavior of this agent is defined here. In this case you can see the code run. This is the one which will trigger to extract the data, and then we have defined the prompt. Prompt is not hard coded in this Python files. Prompt is actually is decoupled from this folder. And we have calling the Claude API here. You can see the model, uh, tokens, maximum token, system prompt, and then this is the message user role. This is the real call for the Claude Anthropic, and then we are recording the LLM cost. This is one of the another feature of this application. Say for example, if a finance team in the organization wanted to know how much money we spent towards this LLM AI and all. In that case, we wanted to know, okay, uh, what agent costs this much money. We have many agents, which agent is costing more money, or which policy in costed us more money towards API calls, and then which model, whether it's a sonnet model or haiku model, costed more money, like that. Those kind of things we need to find means. So each and every agent we need to have such method like record LLM cost. Yeah, and these all the extraction techniques. And then this is the schemas.py file. Here you can see a list of properties under a class. These are all the properties which will be captured as part of the extraction process. And then same thing, claims history agent. Here also we have a similar agent.py file, schemas file. Here the claims agent file will try to understand how many claims are there for the customer in the past by coding the vector database. Here it is a Postgres database, but still pg vector column will be used. uh, yeah, and it will find a list of claims the last 3 years, list of claims the last 5 years. Those kind of information will be fetched from this agent, and it's having its own schema file for those fields. And then we have other agents. Same, every agent follows a similar structure. And then the underwriting risk agent is the one which takes input of the previous three agent: document ingestion agent, claim history agent, hazard evaluation agent. Based upon the output of these three agents, this will determine whether the risk has to be accepted or refer. In case if the risk is declined initially, that means in this phase itself the subsequent agents, the second agent onwards, will not be triggered. Okay, only in case of non-decline scenario it will proceed further. If it is referred, in this case it will stop here, and then pricing agent, this agent will not be triggered if it is referred. If it is not referred, pricing agent will be triggered. Pricing agent is the one which will calculate the premium, excess and all. Okay, this is the pipeline folder for the agents. And we have a platform folder. Here we have a governance agent. What is governance agent? It is nothing but a set of rules and regulations defined by the government or insurance organization in this case, where we need to abide. Those kind of things are defined under here. So this agent will be triggered after the all the previous agents are run, because this agent needs the output of all this previous six agent. So this is the governance agent. And then we have some folders dedicated for cost tracking, and this is the one which will be helpful to display the metrics, the dashboard in the UI. So dashboard.py file, which will is a UI file built in Streamlit. uh, and if you this file serves the UI related things for the metrics. And then yes, pricing is the one which defines the cost of the different models. And we have something called database. database. Here we have connection.py file. This establishes the connection with the database, and then we have models. Models is nothing but the uh, yeah, this is similar to the entity framework we have in .NET models. Here we have some similar structure which will be helpful to interact with the database. And then we have orchestration under the platforms. Here here there'll be a file called workflow.py. This is the main file which will orchestrate all the agents. So here you can see the land graph being used. So this is the framework we are using to for this orchestration. We have all the relevant methods for this entire orchestration. And then and then we have tests for each and every methods written under the agents, as well as we have something called evals is similar to test, but it is not a replacement of test. Evals is especially um, popular in the AI or LLM space. Difference between test and eval. So test is deterministic, which means for a given input, we know what is the output. If the output is matching the expectation, then test is passed. Whereas evals, it is probabilistic. It is not deterministic. That means an LLM can vary slightly for a given same input, and if you execute for different number of times. So in this case, we basically evaluate what is the risk score, what is the confidence level, those kind of things. That is the evals. And we have something called alembic. Alembic is nothing but a um, it's a script file, Python script file, which defines all the database objects. In this case, in my local, I have all database defined already. So for me, it may not be required. But in case if someone needs to clone my repository and they want to have the database structure, they have to execute these Python files. These Python files are nothing but this will create the database object like table and all the database. You can see over here, create table, submission table is created with few columns under it. So workflows table is there. It is actually a kind of a SQL script, but in the Python language. So this is kind of a we can store in the Git, so that any user can, whenever they clone, they have to execute this script. It is Alembic, so it is, yeah. And then we have some prompts here. This is the prompts folder where we have all the markdown files for the system prompts. As I said, we are not hard coding the system prompts in the agent.py file, rather we are decoupling it and having it over here. Say for example, I will click the document ingestion agent markdown file. So this file, if you wanted to have any change in the future, you can straight away update here. No need to update the Python file if you hard coded in that case. So this update will help not to restart the server and all. So that's why it is decoupled in a separate text file, which is markdown in this case. So in this case, this document injection agent, you will have some kind of the prompt injection techniques to help the LLM to be cautious from the vulnerabilities. Okay. Right. And then we have scripts folder. We have some seed underscore data. There's nothing but I wanted to have some master data for this demo, like customers data, policies data, and also I have this seed data.py file. If we execute this, all the some data, it will be generated and inserted into the customers table, different tables. Okay. um, yep. And the this is the env file, environment file will store some secrets. Say for example, my API key for the cloud model are located over here, and this file is git ignored, where I don't want to store such file in the open repository like GitHub and all, so that's why it is hidden. Anyway, we have another file. It's only a template file, env example. This is a file which is used for other users. Whenever they clone the repository, they will know, okay, we have this much of keys, we need to populate these keys with the relevant values so that they can work locally. Cool. And then yeah, we have a claude.md file. This is a file which is used by the Claude. Whenever a new session is launched, Claude will look into this file. Docker compose.yaml file. This is the file which is used to establish a connection with the database. And then Docker file is for the deployment purpose. And then we have something called interesting py project.2eml file. This is nothing but a, so in the olden days we used to have requirements.txt file under the Python that will define all the required packages we needed for the application. So now instead of that we have something similar called as py project.2eml. So all these dependency packages are defined over here. So any packages is needed for this entire application are defined over here. This is similar to the project file in the .NET world where we have some references to the NuGet packages similar to that. Okay, and then we have something called uv.log. It is in Python world. It is similar to this py project.2ml. However, this is locked file. This file we cannot update. User will not update. But whenever we do a sync, any files used over here that will be coming over here. So this will be useful whenever we raise a pull request. We can ensure okay, the others whoever does a review, they will know anything we have changed in this application. They will come to know this to the change in this file. And the readme.pmd file, this is nothing but a classical readme file to help the users to understand about this file details, everything, the functionality, how to install everything over here. This is readme file. Yep, that's it. Now I'll launch this application. Okay, we will start with uploading a simple document. Before I upload, I just wanted to tell you I've designed this demonstration to upload only the property kind of risk. Say, for example, if someone is having a building or a property, they want to insure that only those kind of policies we can insure here. If they want to insure their car or motorbike, we have options defined, but at the moment I'm not supporting anything. I'm supporting only the property. In future we can extend this application. Also similar to that, I have a jurisdiction. This application supports only the New Zealand. That means law or regulatories from New Zealand government only are used here. Yep. And then yeah, I'll copy some content here. I will go to the samples, documents, clean auto upload, the first one. Okay, this is a classic vanilla flow. I'll be uploading this. I'll copy pasting this, not uploading. So this will take some time. So all the agents will be triggered in a sequential manner. First document injection. Yeah, once it is finished, the next two agents are in parallel execution. Claims history we will call the RAG to understand any past history of the customer in terms of claims. Hazard evaluation, these two are still running. These three agents output will be used in this underwriting risk agent. Now it has started. That means the previous three agents are done. Okay, if it is a classic scenario, it will proceed to the next pricing agent. Otherwise, it won't. But in this case, it will proceed to the pricing agent. Let's wait for a couple of seconds or a minute. Yep, pricing agent has started. As I said earlier, each and every agent calls different cloud models, not the same cloud models. Governance agent, we send some more tokens because it considers all the five previous agent outputs, and we have some regulatory rules defined in a database itself. Um, it will fetch that and then it will evaluate. Yes, policy is created. It's green now. This is the policy number ending with 719 PPY. I given the convention of PPY because the property policy. That's it. So this is the results of this entire process. It is accepted. The risk score is 0.17. Confidence is 0.87. Risk is very low, and the factor 0.717 is very confident by the LLM. This all the report, and the premium is $5,040. Final premium is 3,528. Excess is $400. So the policy conditions, all our insurance related terminologies approved. Okay, so you are seeing the premium because it is approved in this year itself. Okay, so we will see a couple of other examples. Say for example, I'll go for the prompt injection scenario. Okay, this is because it's having some vulnerable text. Okay, if I copy paste here, click run up full up pipeline. Yep, it won't trigger any of the second agent or third agent onwards. It will stop in the first. Yeah, submission declined. why it is declined, how the policy has been created, policy number has been created. Okay, prompt injection detected. And it also highlights what is the text, what is the prompt injection. Ignore all previous instruction. This is actually a classical instruction to LLM we normally give, but unfortunately the document is having such content. Hence why we flagged this document. Okay, that means the user has to clean up this document and upload a fresh. Okay, and then this is a another decline missing fields. Some mandatory fields are missing that will be highlighted. I'm not going to use that. Rather, I'll go for the referral sum insured document. In this case, the sum insured is quite large. So in that case, what will happen? The system will refer. It won't show the pricing here. Okay, first four agents will trigger, whereas the fifth and sixth will not be triggered here because the sum insured, the number is figure is will be big. Let's wait for a few seconds or a minute. Yep, awaiting human review. This is the policy number ending with 597 PPY. Yep, it is refer. Risk score zero point 0.8. Risk score is slightly high. Confidence is 1. So this is the reason because sum insured is greater than 50 million, which is quite big. Awaiting human review. Go to underwriter queue. In the real-time systems, there will be a separate application or based upon the authorization, authentication, we will have a different page. But here for demonstration purpose, I built everything in the same application, same authentication, same user. So here you can see this. Yeah, it has been. I click that policy. So here I am going to uh, one moment, I'll go back and come. Yeah, this is the policy, correct. This is the policy. That one is old one. Yeah, this one here. Yeah, it took some time to get this policy. That's why we are seeing some other older policy. Yeah, here the same details refer, everything is there, no premium. Now I'm going to approve this, the default value is approve it, the other values you can see is approved, decline, override, approved conditions and all. As a senior underwriter they will approve saying okay to approve, something like that, and then I'll give click submit decision. This will trigger the remaining two agents which was not triggered in the previous flow. Okay, pricing agent has started. Next governance, think pricing is still going on. Yep, pricing's done. Governance. Yep, done. Okay, pricing is 62. Premium is $62,400. Quite large premium because the sum insured is 50 million. Excess is $6,200. Yeah, outcome refer to senior underwriter. Yes, this is the lookup. So if you want to search any policy, you can give it over here and then look up. It will take some time to get the results. Yes, good. Awaiting. This is what we have seen, and we can expand it to see the data in the JSON format. If you want to change the format, we can change. But at the moment, I'm showing all the extracted all the data in the JSON thing. Okay. Then audit trial. If you wanted to check the audit, what all actions happened with that policy, that will say, for example, if a real time auditor wanted to investigate, that means we can give this provision, they can check okay, these all the agents which worked on the policy, what happened, when, time, date, time, what was the confidence, everything can be derived from here. Okay, so this is the audit trial. Right, next LLM cost dashboard. This is one something I'm so interested. So here total spent USD $5.94, 429 LLM calls we made. this much of tokens we have passed and this much of tokens we have got. Output tokens, cost by agent, we have 6 agents and each agent contributed this much of cost. Underwriting agent $2 something, governance agent $1.4, blah blah. Cost by model, cost Sonnet $4.9, which is expensive compared to Cloud IQ 1.0. So if you sum it up, you will get the total cost over here 5.94. So it looks like it is accurate. Daily spend, some trend, cost of class of business. As of now, I'm using only property. That's why only property is there. If I have some other risk, it will be like the other bar graph. I mean, other bars in the graph. Cost per jurisdiction. Of course, I only New Zealand. Token efficiency by agent. Each agent, how much of tokens cost, everything detail, raw cost ledger. This is quite interesting actually. Yep, that's it. And the screen gets refreshes every 30 seconds. These things I just gave instructions to the cloud model when I was developing. It made a very good UI. It seems that's it. But in future, I am interested to extend this application with other risk types, liability, motor, and all. Also, I'll try to enrich this application in whatever way I can do. Thanks for watching. Let me know if you have anything to say. Cool. See you.